Hi, good morning, everyone. I can't believe we're all here. This is great. I'm not even awake yet. Let's see, where's a good place to stand? This is a good place to stand. Hey, everyone. So I'm Jason Swartz. I want to talk about functional database strategies today. But not really talk about the NoSQL. I want to talk SQL, old-fashioned databases, relational databases. Mostly talk about most things on Postgres. I know that there's a lot that you can talk about with NoSQL and making them immutable and workable for functional programming. I'm going to take a different tack, assuming that you're going to work with old-fashioned relational databases. So I'm Jason Swartz. I tweet probably too much now as Swartz Rock. I've used databases a number of different companies I've been at. It's only more recently that I've been looking at the functional aspect of working with databases, how to make them immutable, how to make sure that you don't have mutable state, and that all the lessons you learn in Scala and with functional programming languages, that you can apply them to databases. I also like to talk about Scala, which is why I'm here. This is not so much of a Scala talk this time, but I love talking about Scala and helping out at Scala by the Bay. So that's why this is going to be a not super Scala talk, but it's going to be a functional programming database talk here. All right, so the main strategy for functional databases is buy yourself a functional database. I'm just kidding, there's no functional database. Okay, but databases, they're mutable typically. We think of them as, you store your state in there and you get it back. In fact, you can have a nice stateless instance and have totally immutable data and let the database do all the mutating that you need. I mean, that's typically the way to do it, but, well, can you have immutable data in a database? I mean, can you use it like that? So we're going to look at these different areas. We're going to see maybe you can apply the functional programming knowledge that you're experiencing as you develop Scala to your database. We're going to look at being able to lock down your rows so you can't touch them at all. We're going to look at the new windowing functions you have in SQL 2003 and later versions which are available in Postgres and other high-end databases. We'll look at maybe storing state isn't even the right answer. And then we'll look at some ways that people manage to handle their database transactions in kind of a Haskell way by wrapping things and separating them out to avoid errors with shared mutable state. So all these areas are functional. It may or may not be functional programming, but it's an interesting way to think in terms of, well, we like immutable data, we like functional programming. Let's make sure we don't forget about our database. Or, buy a functional database, wherever that is. All right, so immutable tables. Well, I want to start with an example. So let's say I have okay, we're all like developers here. We love, Jira and bug reporting and stuff like that. Okay, so let's say I have an app. My app is called Tasks, and I'm keeping track of a few different bug reports. The high-end functional Scala, type of experience I have is a big monolithic web app and a database. That's my model. Don't tell anyone about this. And let's say I have something basic like this. I'm using Postgres. Well, this is not hard to do. A lot of people do these will have APIs that wrap databases. I mean, even as good as we are at engineering, we often end up running one of these somewhere, or many of these. So in this case, I'm modifying issues. Well, what happens when I modify an issue? What happens when I do the create, read, update? Well, in this case, can everyone see the top part and the bottom part? All right, great. So let's say we have a post coming in talking HTTP now. Well, that's great. We now have this new database entry here. And then we go ahead and update it and say, I've assigned it to you, for example, which people love. So, we have assignee. That's nice. And then we mark it as done and we're good. So it's, well, this is not very hard to do. Is there anyone who hasn't done something like this already? All right. Or who hasn't had enough coffee? All right, me neither. Great coffee. I love the coffee. So this looks okay, right? I mean, it's pretty standard, but how did this table get this way? I mean, look at this thing. It's a table. It's a tuple. It's a collection of. It's a single row with a collection of data there of different types. But how did you get there? I mean, how can you look at a row like this and extrapolate up to the events at the top? Well, what if I take away the events at the top? How do I know just from the database how I got here? I mean, it's really hard, isn't it? You can't really say, oh yeah, that's how I happen to get to this fun collection of items that makes up this table row. Even if I show you the events that led up to it, can you figure it out? I mean, does anyone notice anything wrong here? Other than I'm really dressed too nicely, I think, for a Scala event. Yeah, Signey's null. Fantastic. Good catch. How to get null? I don't know. We were mutating the database. We have no idea how that happened. I mean, that's kind of tough. When your rows are mutable, you don't have any history. You don't know how you got there. But if you make the table rows immutable, you're going to have a whole history of everything that happens in your database. You're actually going to be able to see what happened and keep all the same functionality. So let's say maybe we don't want to be mutable. What if, in fact, every time we do something in the database, we just throw in another row? Well, then we start out with a post, and as we do a put, we kind of add another row instead. And then when we do our final put, we look at this and say, whoa, what is that? I don't remember putting that in. Obviously, someone threw this in, right? So now I have some kind of history here. I can see okay, 1819, someone set the assignee back to null. Weird, was this an accident? Where'd it come from? Did it come from an internal job? Can I look in my logs? Either way, I know that I'm not necessarily crazy because of this. This actually happened. Something actually changed it. I can actually tell. When it's time to actually get it, it's not very hard. I can just do a DB query that says, look, just give me the latest one by issue 1. So all my creation and updates work fine. When I want to get one back, I can just get the latest. It's a much better database model. Now each row is unique, is immutable and untouchable. I have a nice record of everything that happened now in my database. Do we have a subversive guy here? All right, I just came up with that. We're going to keep working on that. All right, that was good. So your tables are immutable, of course. You can keep inserting all you want, but each row that you have, every tuple, should really be immutable. There's no reason that you should have to change this. In other words, you should be able to put stuff at the end of your table, but there's no reason you should do anything other than that. Well, you should query, but the only change should be append only. So how do you make one? Well, the big thing is, if you want your tables to be append only, don't let users update and don't let users delete. It's that easy. This is Postgres. There's probably a way to do this in MySQL, but it's a little more work. In Postgres, if you say, I'm giving you select and insert access, it means you don't have any other accesses. You can't do anything else. I think you can still create tables, but you can't modify this table now. You are locked down. If you do this now, your app won't accidentally mutate anything at all. So that's it. No, there's not. There's more. Think about the right columns to have here. Okay, I have this, but it looks a little bit funny. What I really should do is consider having more than one way to look at a row. Again, I have an ID, but it's weird to see an ID with multiple entries, right? What I really want is I want to consider this to be its own entity with 4 different versions of it. I still want to have a row ID. I still want to say, hey, I have a unique identifier, but I also want something that'll follow this all the way down. So look at this one. I've added one column here, issue ID, saying, ID serial, which in Postgres means it's an int, and you should just generate it whenever you put it in there. Cool. My table now has unique rows identifiers, but I have an entity ID. I have something called an issue ID, which means based on this, when I do an insert, it'll pick a new number. And then every time I update it, I say, hey, I want to update, I want to insert, and the issue ID is this. And then, I have something that tracks all the way down. You can see I have an ID here, I have a unique identifier, but I also have something which tracks my entity all the way through. So now I have 2 different kinds of identifiers. The nice part is, if I want to say, hey, here's my issue, I'm going to send an email out, or I'm going to link it on this site, or I'm going to show it, I can use the first column. because that's immutable. That never changes. I can make it global. I can share it with anyone. The issue ID is mutable. I don't think you should share that with anyone else. That's going to change. So if you have to say, if you're going to bill someone, or if you're going to do something, if you're going to do some kind of reconciliation, yeah, know that issue ID, the latest version in the database may not be the one you're working with. But if you use the ID, you know that's never going to change. It may not be eventually consistent. If I say, hey, I'm looking at issue with row ID 3, I know that that's not going to change behind me at all. It may not be the latest, because it's not really consistent with the database, but it's safe. I can refer to it, I can pass it around, other people can come back, it's never going to change. Anyways, that's the part about row IDs versus issue IDs. Are there any questions between the two? All right, send in more coffee, please. No, I'm just kidding. Getting the latest item then is not really tough. If I have an entity ID, I could just say, look, give me the latest item, the most recent item with that entity ID. It's very straightforward. This is very basic immutability in table rows. This doesn't work for everyone. Notice that I'm just getting a single item back. If you want to then be a little bit more advanced, like you want to be able to say, hey, I want the latest of a bunch of different items, you're going to want to use something like window functions. So the SQL 2003 standard makes it possible to change the regular group by and have a whole suite of functions to act on whatever you group in a database, which works great. These are available in Postgres as of the latest MySQL. They're not in there. I believe they're in Oracle and some other commercial databases as well. So you have the ability to do things like, well, I want to aggregate. I want to say, hey, for everything if I'm going to go through all my issues, I want to kind of correlate them based on assignee. Or if I have sales, I want to say, I want to get the sum of all these per state, for example. So you have the ability to aggregate a large number. Use the over function to say, here's how I want to create a window in my group bys. And then you could group by different ways, such as partition. So these are SQL 2003. It's been about 13 years since. And I wasn't familiar with these until recently, but I find them really, really useful. Okay, so here's my database again. I kind of took out the date column because it looks a little messy. So you can see here I have two issues, right? And each issue I've modified once. So the table IDs row IDs are great, 1, 2, 3, 4. But I only have two entities here. How would you get the most recent? How would I say, hey, give me all the most recent issues and select the most recent one of each? Well, then that's a little bit hard. That's not just ordering by date. This is a table with immutable rows. I will never change any of the rows. I'm just going to insert changes here. So here's an example query. I know it's a little bit complicated, using SQL 2003 windowing functions to say, I want to actually separate things based on the entity ID. So the core of it is saying, look, I have these issue IDs. Create little windows for each entity ID. So for example, there's 2 rows. And in this case, saying, look, for all the entities for all the rows that match an entity ID, order them by ID descending, which means the most recent one is first. Then I want to say, look, I want to get the row number of it. So the row number of the most recent one will be 1, and then the second ones will be 2. And then I want to limit this to issues where, maybe only created in the last week. So I'm using row number, which is the aggregation function, which just says throw in a new column that tells me the ordering. I'm using over to say I'm going to create a little window, and I'm using partition to say, or group them by their different issues. So what I get back from this is, when I'm saying I just want the first row, well, here's what it looks like when I don't filter out the row numbers. When I do call that function, I don't say, we're row number, there's now a row number. And it's saying, look, create a little window for each entity ID and order it by ID descending. So ID 2 is more recent than ID 1, so that gets the first row number. And similarly, for the for issue number 2, row ID 4 is greater, so it says that's the row number. So then I just say, well, just give me row number 1 for all these, which means give me the most recent entry for each item partitioned by issue ID. So that works out great. I now get the most recent entry. Well, I don't really need row number because I'm not gonna access it. And now I have everything that I could do with a mutable database. I now have a very easy way to say, hey, for each issue, give me the most recent item in here. I can use this for grouping. I can use this for joining. I don't have to have a mutable table now. I can use these functions to create these virtual mutable looking tables that are really immutable and are safe to use. All right, so that part was window functions. Any questions about these? Yes, sir.
Yeah, so a non-trivial partition might be interesting. It's possible to do that partition expression can be a non-trivial. I'm practicing the same thing. I'm kind of doing this a lot.
Yeah.
But I'm learning a little more, and so that partition by can be an expression. And
right.
That's a door to an interesting architecture.
Well, it can be, like, for example, if you can group by two things. So you can make that part a bit harder. The main thing I like to do is I show the row number. So I do the queries and it's like, well, what's the ordering? And I'm like, oh, that's how it orders it. Because, for example, sometimes I'll order it and I'll change the ordering. You can have case statements in the ordering. So you can do something similar to Scala's match expressions inside the order that says, hey, does it have this flag set? Yeah, okay, we'll put this first. If it doesn't, no, just use the regular ordering. So it's really interesting. This is the functional part of these data space strategies. Was there another question? Yes, sir.
Yeah, I'm just wondering if you're doing this kind of dynamic query on a production system, do you want to go to a materialized view, or at what point do you go to event sourcing to materialize this?
Event sourcing makes sense. I usually don't like views because people forget them and then can't find them, and then you're like, where's this thing coming from? Which I've done with legacy systems. I would say run an examine on this. Make sure that you're hitting the indexes. Or indices. There's no reason that you can't hit all the indices with this when you do the partition. In this case, I'd make sure that issue ID and ID are indexed separately so that you'll hit this correctly. Does that make sense? But I mean, with both MySQL and Postgres, it's pretty easy to say, tell me how this query is going to run, and then you can get a good feeling for how it's actually, if it's cached and what indexes it hits, or if it has to do a full table scan, for example. And I'm pretty sure in Postgres you can say, look, don't optimize for table scan. Assume that I just want you to try to hit the indices, and then you can get a good feeling for that.
Okay.
I can't believe I'm talking about good feelings. It's a science. It's a science. No, but when you try this out, show the row numbers. There's no reason why you can't add this in and return it. You don't have to actually read it, but it's a nice, useful way to say, oh, okay, that's how my query's ordering things. I only want the most recent one, but it lets you experiment and try it out and see what you're actually getting back. And again, the great thing is, so we're using this at ClassPass. We added the ability for people to buy bundles of classes, and we said, well, our bundles are going to change. We're going to have marketing people keep changing the prices. So we have the concept of kind of a bundle, but we use row IDs. So when we show people a bundle to sell them, we say, don't use the mutable one, use the row ID. So we say, hey, this is now available for 30 bucks. And if marketing says, hey, that should be 25 bucks, it doesn't matter. We're showing the user the row ID. When they buy it, they buy the row ID. We say, look, even if you change it later, we're offering you the immutable one because we don't want to switch things around. So this is the basics of windowing functions. I find they're really interesting. They give you a lot of, especially with summing, with averaging, with the ability to say, hey, I don't want to do a really tough group by, I don't want to do subqueries. I just want really smart functions when I go through my data. All right, we're halfway through. How are we on time? Are we good so far? Well, I'll just assume we're good. All right, so we talked about state so far, which is great. But what a lot of people have is not really state in their system, do they? A lot of people have events happening. Are people pretty familiar with the term event sourcing? Cool. Is anyone really tired of it yet? Okay, good. Then I'm going to talk it through. All right. So you've seen this, right? Here's my little HTTP actions at the top, and here's the table that gets generated at the bottom. Well, really, these are events that happen at the top, and they result in state. Hopefully, it's mutable across the table, but each row is immutable, but still I'm storing state here. So I'm having like, hey, create this issue, which then gets put into a created issue, and then when I do assign and complete it, gets updated. No, it doesn't. It gets inserted because we're using immutable tables. Yes, immutable tables are great. Okay, but I have these events and I'm storing them as state, which is nice. I'm keeping track of all the states. I can see all the states that I've stored, but is it really necessary? I mean, if events are what creates my state, maybe I should just store the events. You know, do you really need to keep track of the state of things if you can generate them? Maybe these states are virtual. I mean, if I know what the events are, I can just create the state at any point. I can say, hey, what's issue assigned state look like? Well, I'll just do create issue and assigned issue because I'm keeping track of the events. States are just a manifestation then. They're just a transformation of the events against a starting state. So you're storing state, you're storing events now. Okay, well, if I want to store events, probably my table looks a little bit different. Probably I want to keep track of something like an originator, figure out where it came from. And then the core business data I could have in some kind of payload. If you're using, if you're using a non-statically typed system, I could actually have the rows here, but I want to keep track of where this came from. So let's try this again. Let's say I do a post and I say, hey, this event, here's an event with a nice event ID. Like, actually, your ID might be better for this. Great, I can store that. I can say, I'm going to track the event. The states I can just generate at any point. The states don't matter. If I have my events, and my events are completely immutable, never changed at all, it works great. So here's my create issue. Well, my virtual state is that I have the starting issue. Well, now I have an assign issue. I have a second issue coming along. Okay, here's the state. Okay, now I've completed it. And we can say, oh, here's the state. State is just generated. It's very easy to do. I have the events. I can create the state. I can create the final state. I can create any part of the state. I won't go into this a lot. A lot of people find that if you have massive data streams, it works out really well just to store the event and don't worry about updating and dealing with database, changing anything in the database. I won't go into this. I'd say it depends on your system. If you don't have massively high performance needs, it may not be necessary. I really like number 3 and 4 though. The idea that, look, now you manage states, now you manage events, you can create any state that you want. I mean, you can undo something. You can say, hey, you know that third state, that wasn't any good, let's remove it. You can say, great, we'll just generate the state from scratch. So it's kind of like, right, having control over the versions of your state, which you can generate at any time. It's like having something which, your data now, you see everything that led up to your data and you could change it. I mean, if you think about it, yeah, wouldn't you say it's like having Git for your data? Yeah, well, there you go. You have you're keeping track of everything that happened. You can go back and change things. It's an immutable time stream, but one that you can reorder as necessary. You now have full version control for all your data because you're not storing the state at any point. That's just generated. All right, not saying it's the best. There are reasons not to go with event sourcing yet. For example, yeah, it's a little bit weird. 2, you may not have an event-based system. You may have history. You may have things which are pretty static. You may have assets in your database and not really events. And it's still not really standard in most companies. But then, hey, we're Scala developers. Who cares about standard? We're not going there. We don't care. Yes, question?
One objection that's not on that previous slide, if you're not holding on to state and recomputing it on the fly, how is that not an O(n) operation to get the current state?
Well, I don't know. But one thing some people do is they cache it. They say, look, if you want the most recent state, we could cache it somewhere. We could have some type of temporary table that you can't write to, but you can read from, and say, if you need this, we can generate it. Nice thing being, if you say, hey, this event at this time is invalid or doesn't work, you could change it, regenerate your cache. But yeah, it is a concern. You don't want to have to then read in everything. But in many cases you can. I think having a view or a cache at some way to say, here's the current state works out great, but make sure it's a cache. You can't write to it. You can only read from it, you can invalidate it, and you can represent it that way. Does that make sense? I'm glad you asked. Great. Oh, here's the clicker. So, yeah, we're Scala developers. This isn't going to stop us. Not saying it's the best for all approaches, but it's a different way to think in terms of state, especially compared to mutable state. All right, so that's the event sourcing part of it. The last thing I want to go over is pretty short. I want to talk about now how you're actually working with the database. We've covered making your database, your tables immutable. We've talking about using window functions to make the most of having immutable table rows. We've talked about, well, maybe databases are not where you should actually store your state. Let's talk about working with your database itself. So again, your database and your interactions with it are still kind of mutable. You still have the ability to have some type of state, and you still need to worry about it. For example, do you have some kind of session that you're passing around? Could it have different state? Do you have a global or implicit session that's being passed that might change how your program works, make it less, increase the likelihood of side effects? Do you have, well, everyone knows what a cursor is, right? You do a query, database says, I'm ready at row 1. Do you want to read it? Yeah. Oh, row 2. Oh, cool, I'm standing here. Just let me know when you want to work. I usually just read everything at once, but sometimes that doesn't always work. But then you totally have side effects. If you have a cursor and you're passing things around and you're reading it in a non-managed way, you could have very odd interactions happen. It's totally, well, you can think of it as being totally unsafe. The other area is, where are you writing state? Are you writing it in the middle of your application? Are you doing side effects? Or are you saying, no, I'm going to have mostly pure functions. I'm going to model everything as an update. I'm going to have some type of, maybe monadic collection that says, well, here's a collection of my updates. At the very end, I'm going to map them into actual updates in the row, but I'm not going to actually change things in the middle of my program, which would be side effects. The last thing on here is, again, if you're going to change state or you're going to introduce a new state, and make sure that you're not doing this in the middle of your functions. Keep your functions pure. Make sure you have referential transparency, that you can call your program over and over again. You could replace a function with the actual data you return, and when you do need to update state, when you do need to make changes, make sure that they don't affect your code. So there's a lot to do yourself, and I'm kind of lazy. I don't actually want to show you how to do it yourself. So I'd recommend checking out Doobie here. Is there anyone who's not familiar with Doobie? Oh, okay, great. So this is one of the type level projects. It's really nice. It doesn't say, hey, I'm going to handle all of your object relational management here. It says, I'm going to help you work with your database in a safe manner so that you can reduce the likelihood of being hit by shared mutable state of your database. One nice thing I like from the Doobie docs is that, again, it says, look, here's all the different things you're probably going to do when you work with JDBC, or you have a system that takes you through JDBC. You're going to have a pool to a connection to a prepared statement. These are all the steps of how you get to actually working with a database from a JVM type system. But maybe they're not steps. Maybe it's some kind of monadic data structure that you can build and you can add things to which aren't actually executed until at the edge of your program, or when you return control to say, okay, go ahead and execute all these now. Don't do it in the middle of my program. But you don't have to take this from me, folks. You should probably take it from Rob. Rob's here today. He's the main developer of Doobie. He has cool little hexagonal Doobie stickers. I don't usually like to call people out by name, but I love meeting people at Scala by the Bay and talking about the projects that they're on. So if you like Doobie or you want to talk about other projects, find people who worked on it. They could be here. It's a great way to get to know them and for them to get to know how people are using their software. Sorry, Rob, if you're here. So that's the part I really want to talk about database interactions, to make sure that you're using the database safely. No, I'm just kidding. That's a whole talk, everyone. Oh, yes, question?
In practice, how do you solve the problem that your production, web-facing database only ever grows? Do you go compacted mainly? Because otherwise, you're going to have to just keep adding machines to this, right? Because if you went with the event source version, like you must have everything to rebuild it. At least with the state one, you can drop the old versions and kind of keep pruning it. But what do you actually do in practice with this?
Oh, yes, thank you. So it's a great question about the fact that if I'm having an immutable table, I'm just going to add rows, it's really going to fill up databases on more active sites. Is that your question? We haven't had that problem at ClassPass yet. That's a good question. I haven't really experienced that. We aren't using it for things like logs, for example. If you have something which is really big and grows with traffic, like you have some type of event collector system for metrics, I'm not sure MySQL is the best place for that. You'll probably want something, a good system which can automatically clear out things. But again, I don't think it takes up a lot of room. I mean, these are pretty small tables, and they're thinking in terms of events which modify, not singular events which will never change. To be honest, also in a lot of cases, your database does update the row, but often keeps the original row around. If you're using something like MySQL, you'll find there's massive files you probably don't want to look about, which make sure that its internal format is append only. That's a great question. We haven't had to look at that. I'm sure you can roll it up. We've had issues with like database migrations. You know, when you get to 100 migration files, you're like, hey, let's stop, set a key state, and start over again. I'm sure you could do the same at some point if you have a lot of data here as well. I don't have really a better question. I would probably figure out what areas you have. If you have vast amounts of data which represents mutable rows, yeah, you may need to look into some type of sharding situation or something which can grow over time. Does that help? It's definitely a valid question to think about. Yes?
The kind of standard answer to that with event sourcing is a snapshot store, right? Where you can take a snapshot and then discard all the events before that.
And say, here's the starting state.
Here's the start of the state.
Right. Again, it depends on what kind of events you have. I mean, I would think it's still always useful to be able to go back and look at that. But you're right, if you are keeping track of events, and these are events which you need to turn into state to keep track of them, I'm sure you can say, instead of starting from the beginning, and this is something where it's just going to change a lot, you could do that. I wish I had a better answer. These are great questions. I'm glad no one's asked about how are you going to do some kind of crazy transaction across a immutable table. Yes?
What do you find to be the best way to evolve the structure of your events over time?
What's the best way to evolve the structure of your events? That's a great question. We've tried using JSON as the payload here because we want this to be used by a lot of static type and dynamically typed ones. I would recommend thinking closely about the payload again. Make sure that your payload, you could use columns in your payload, or you can use some type of embedded structure. I'd make sure that your embedded structure is always going to be, that your code's always going to be backwards compatible with older versions. That's the nice part of doing something with some kind of embedded model, so that this can change as necessary. I mean, that's also a problem. You do want to be able to change the format of your data without actually modifying the rows. If you have to add a new column or change a column, that kind of changes the data and it changes the event. That's a great question. It's probably a good reason to have some type of separate payload that's not modifiable. Super question. Yes?
Any thought on handling base conditions using sourcing paradigm?
Wow, these are great event sourcing questions. This is wonderful. What about race conditions when we have, say, multiple events coming in? What some people do is they say, here's an event, and it's based on the UID of a previous event. So you may want to think, if this is an issue, think of a state transition where you say, hey, I have an event where the originator is this previous event. Therefore, if you get two different events and they have the same originator, it means they're both trying to update the same thing. It could be that you choose the first one and discard the second one. This is often an issue with distributed systems where you could have multiple delivery. If you're using queues, for example, if you have something, some kind of streaming data, you totally might get multiple events and you want to discriminate and choose, okay, given that these both update for these are both updates to a previous event, you may just have to pick one of them. It's a good question. It's a good reason why you may want to have something that uniquely identifies an event and say only items which update the latest event are accepted. Killer. Hey, how are we on time? Nope, I forgot to check. Wow, this is going great. I think that's about it. This is Functional Database Strategies here at Scala by Scala by the Bay 2016. I'm Jason Swartz. Thanks, everyone.